So let's get into the block side. Now you'll notice as we go through these slides that I have this static graphic over here on the right, so you can reference and see what a common cabinet would look like with these components in it. The first piece of block hardware that I really want to focus on is the storage processor. Now this is the meat of the array itself. This is all the intelligence is built into the storage processors. Now these are dedicated block processing servers, they're x86, and they're the ones that are responsible, there's two of them, for all the VNX line, dubbed as storage processor A, storage processor B, SPA, SPB is common terminology you'll hear when referencing the SPs themselves. Like I said, there is a lot of intelligence built into the SPs themselves. It is handling RAID, your data availability with rating, storage pools, any layered software such as fast cache, SnapView, any of the layered software that goes on the array itself, that's all managed and processed on the SPs. Now these guys are multi-core, multi-processor. I like to call them, and I think I've referenced them in previous lessons as intelligent RAID controllers. They do a lot more than that, but I think people understand that. They understand what RAID controllers are. They've been around for years. This is an intelligent RAID controller. It does so much more than that, but it's a good reference to it. As I mentioned, these are ingest points for the block protocols, so your iSCSI, fiber channel over Ethernet, all via these UltraFlex I/O modules. And you'll see as we progress through this some of the options you have when it comes to UltraFlex I/O modules. Now this would be on both the SP side and the data mover side, so the UltraFlex I/O modules are referenced on both the file side and the block side as the same. Now there's different options as far as cards which are available, but when you're planning or designing or buying and you want to make sure you have enough modules to fit the incoming data center traffic from your servers themselves or directly from your customers or your employees, and you also want to make sure you have enough back-end connectivity to the SPs if you're coming in from the file side, or directly to the disks if you're talking directly to the DAEs from the SPs themselves. You want to make sure you have enough UltraFlex I/O modules. Also on top of this, there's a single pane of glass called Unisphere. We'll get a little bit into that as well. And also at the end of this lesson, I didn't mention, but there will be a slight lab that'll kind of walk a little bit, start getting into the components of Unisphere. We'll go over some of this hardware itself and how you will view the hardware within Unisphere. So if you do see something that is you get alerted on, maybe via SMTP or SNMP, that you'll be able to go into the Unisphere itself and you'll be able to dig down until you can see what the actual failure is on the SP itself, or whatever the component is within the array. Now a lot of that stuff filters up to the main dashboard that you'll see within Unisphere itself, but this will show you kind of the process and some reporting capabilities and things like that you can view within Unisphere. Now each SP itself has 1 copper GigE port per SP for management. So this would plug in directly to your network as a customer, and then that's how you would manage it. So it would have an IP address on there. You'd set all that during the setup process that is typically done from your partner that is installing your array. And also the SPs are an active passive failover design. We'll get into a little bit about Lua and how that kind of flips that notion on its side. But in general, a LUN is owned by one SP or the other. And to me, that's active or it's passive. The other surviving SP or the other SP, if it's still online, does not have the capabilities to ingest I/O across that SP if it's the passive SP. You're only going to have one stream going from one host to a single SP at one time. So keep that in mind. Also, point-to-point connections to back-end disks via the SAS bus. I mean, that's the SPs have this point-to-point connection. It used to be fiber channel arbitrated loop architecture, which was extremely robust at the time, but now it's been replaced in the VNX with the SAS bus. Everything prior to that was a fiber channel arbitrated loop bus. So what's the storage processor enclosure? You would guess it. I mean, if you had to guess what an SPE was, what would you say? Well, I would say it's a container for holding the SPs. And that's exactly what it is. Now it's 2U in size, it contains no physical drives, and the reason I mention that is because you'll see in lower end arrays that we have what's called a DPE that actually holds the SPs and the first tray of drives. So it's important to point out here that this is 2U in size and does not contain any physical drives. The first enclosure that would hold drives would be enclosure 0, bus 0, and then that would be your first 15 drives if it's a 15 disk enclosure. this is using higher end VNXs, so think 5700 and your 7500 arrays. Now we get into the DPE. Now this is going to be in the 51, 53, and 55 VNX. This will actually contain the SPs themselves and the first 15 disks. It gives it that lower price point, gives it the ability for a lower density in the cabinets since it's themselves. It is a physical container for the SPs in the first tray of disks, as I mentioned. It's 3U in size in comparison to the 2U in size SPE. 15 disks in that DPE. Like I mentioned, it's in the lower end arrays themselves. Now, what's common to all the VNXs is a disk array enclosure. Now, this is a physical container for disks. That's really the most common way to state it. Disk array enclosure holds your disks. It encloses your disks. And you'll see it over here in the graphic over here. Now, you'll have, depending on the size of disks that you're actually allocating within the DAE itself, you'll have multiple enclosures, but this is common how things are stacked. So you have your SPSs at the bottom, your DPE or your SPE, and then you start, if it's just a block only array, then you start stacking DAEs. Now, if it's not a block only array, then you would move on to your first disk array enclosure. Then you'd move into your control stations and your data movers for your file side, and then you start stacking DAEs. Now, what's common is 15 disk 3U enclosure. These have been around for years. They've just started offering over the last couple years, so let's say several years. You can now do 25 disks, and these are 2U enclosures. The 15 disk 3U one disk enclosure will actually hold 3.5-inch disks, and the 25 disk 2U enclosure will hold 2.5-inch disks, respectively. There's also a 60 disk 4U enclosure. I have never seen one of these in use today, or even in the past. That option does exist if you're looking for higher densities. Now on the 60 disk enclosures, only the 3.5 and 2.5 flash 72K drives and 10K drives are supported. The 15Ks are not. So keep that in mind. And then we've kind of started our way at the top and worked our way down. Now we have our standby power supply, which would be at the bottom of this graphic over here on the right. Now this provides battery power to the DPE for the 5100 and the 53 and the 5500. Now it provides power to the SPE, the storage processor enclosure, and bus 0, because bus 0 has your vault drives in it, and your DPE holds your vault drive. So you're maintaining that vault drive capability, which we haven't really got into what the vault drives are, but it is important to maintain that until all your data is destaged from cache. And we'll get into why that is important, but you'll see that in the higher end arrays, the 5700 and the 7500, you have to maintain battery power for the SPE, which is holding the SPs, and bus 0, enclosure 0, because that's where your vault drives are. And that is an area that we want to maintain power to so we can destage that in-flight data in your cache so you don't lose any of that hot data. Power goes out. Just as I mentioned, I'm kind of foreshadowing here as I go through these points. So that allows for enough time in cache, enough for data in cache to destage to an area known as the vault. As I mentioned, in the SPE, your first 4 drives on DAE enclosure 0, DAE 0 enclosure 0 would be, the first 4 drives would be the vault drives. It's also where the OS for the array itself is. On the DPE, same thing, first 4 drives. So you can see why we have to maintain power to both the DPE and the SPE and bus 0 enclosure 0 in the higher end arrays so we can destage this hot data during a power outage. Now physical storage, that's something again that we all know and love. Certainly there's a lot of different options on the VNX itself. One thing I did mention in previous lessons was the disk and OE matrix. Now you can go to support.emc.com. When you log in, you can do a search and just type in disk and OE matrix, and it'll come up with information specific to your array itself. And what it's going to give you is a PDF that shows this information. So it'll show the disk capacity, it'll show the model number, it'll show the part number, whether or not it's NEBS compliant, spin down support, drive type, spindle speed, platform, minimal OE software revision, all information that's specific to your array itself and what drives are supported. Now in general, and you saw this across the VNX model slides in the previous lesson, these are the supported drive types across the VNX line. So you have 100 and 200 gig SSDs, you have 300, 600, 900, 10K SAS, 300, 600, 15K SAS, and 1, 2, and 3 terabyte 7200 nearline SAS, all supported across the VNX line. So what are these I/O modules? They're UltraFlex I/O modules, otherwise known as SLICs. You may have heard SLICs before. You may hear them referenced as I/O modules. You may hear them referenced as UltraFlex I/O modules. All are pretty much the same thing. And there's UltraFlex I/O modules for both the file side and the block side. Now this provides input-output ingestion points for iSCSI, Fiber Channel over Ethernet, and Fiber Channel protocols. Now also NFS and CIFS, there's different I/O modules that are available for the data movers themselves, but this would be primarily for the SPs. I've kind of broken it out into as what I/O modules are supported on the block size, block I/O modules. So you got a quad port 8 gig Fiber Channel I/O module. I have note here, it's not supported on the 5100. You have a quad 1 gig I/O module for iSCSI. This is TCP offload is what TOW means. Dual port 10 gig I/O Ethernet Fiber Channel over Ethernet module. Well, this would be an optical and a twin-X option. So you have the ability to do optical or twin-X for 10 gig. And then your quad port 6 gig SAS I/O module would be for your back-end connectivity between your SPs, storage processors, and the enclosures themselves.